Wonderful students, this is part 2 of foldable number 2. Or sorry, foldable number 2. Foldable number 5. Part 2 of foldable number 5. And this one we have a horizontal translation to the right. And just like we did on the last one, or sorry, not on this last one, but on the one when we did the absolute value or the quadratics, we're going to be subtracting a number inside the parentheses or underneath the here we go. Just extend this out so you guys can see what it looks like. Square root. I know when the computer always does it like this, but if you wanted to, you can actually go like this to show that this is your under. And this is the one we're doing here. So our function we had already was this, and this is our parent function. And now we're actually going over and doing it -1 and putting it inside the square root. Okay? So we're going to go ahead and get going. So we have 0, and 0 came to 0, but we have a -1 here. We're minusing 1. So 0 minus 1 ended up being -1. But once again, I said we're not using, negative, so we're not going to be doing it. So it's going to be undefined. So at 0, there's not actually going to be any points at all. So the next one we're going to go to now is our 1. So square root of 1 is 1. 1 minus 1 is 0. So the square root of 0 is 0. So our point here is going to be at 1, 0. And we can already see this translated over 1 unit to the right. So now we're going to go ahead and go to our 2. So the square root of 2 is 1.14. And then we go ahead and put that in. So if we go 2 minus 1 for here, so the square root is, square root of 1 is 1. So that'd be at 2, 1. We go to the next one here. We're just going to go ahead and skip to 4 since we went to do the numbers we did here. That's what we're doing anyway. So we have 4 square root of 2. But 4 minus 1 is 3. Square root of 3 is about 1.17. So that's about 1.17, which is about right there. I'm not going to put in so much. We're going to go to 5. This ends up being a little wonky here, but 5 minus 1 is 4. Square root of 4 is 2. So at 5, which is 1, 2, 3, 4, 5, we're going to get a 2 here. I know this is kind of weird, but since we're doing a square root, the only numbers that are going to work are the numbers that are square rootable. That's why if you notice here, we had a 9 and then a 10. So we skipped a bunch of numbers here, and then we have a 4 and a 5. Because the 4 is square rootable, but the 5 is not. But when you subtract 1, the 5 is square rootable. Just like the same thing when you do the 4 is square rootable, but the 10 is not. But when we subtract 1 for the function, it's also going to be 9, which is also square rootable. That's why they use the numbers that they did. So we're going to go ahead and skip 9 and go straight to 10 to show this one. So if we have 10 minus 1, we have a 9. We plug that in here, we get square root of 9 is 3. So at 10, which is not even our graph anyways, 9, 10 would be about right there. We're going to go up 3 units and show that it's right there. And we're going to go ahead and draw our nice little shift to the right. And let's go ahead and highlight these as well. So if we notice here, let's see how we're going to show this one. This one goes from 3, 2, 2, 1, 1, 0, 0. And it was one shift to the right, and you notice it is shifting 1 unit. We're going to go ahead and connect these here. And you might ask, Mr. Payan, I don't understand. Why does this one go to 1.14 and this one go to 1.17? And it's relatively simple, actually, because we have the square root of 2 here, which gives us a 2 minus 1 and gives us this here. But when we have 4, this is actually giving us the square root of 3. So this is square root of 2 and square root of 3, which are different. So it would line up better if we used a 3, a 6, 7, 8 on these things here. But since we skipped numbers here, that's the reason why we had to skip this here as well. Or else, of course, if we had 3, 3 minus 1 would give us 2, and the square root of 2 would be 1.4, which would have been there. That's what we show. But we still see that this is one here, one here, one here, one here, which gives us our horizontal translation to the right.